Good day, everyone. I am Riley Saga from IT9. Today, I will explain how I created the table for preemptive priority scheduling step by step. This table helps us track when each process starts, finishes, and how long it waits. So, let's consider a scenario where three students are given a task to speak in class, but they follow a priority scheduling rules. Each student has a priority number, which is a lower number equals higher priority, a burst time, how long they need to speak, an arrival time when they arrive to speak. So here are the details. We have a student A, B, and C. Their priority is 3, 1, and 2. Their burst time is 5 seconds, 3 seconds, and 4 seconds. Their arrival time is 0 seconds, 2 seconds, and 4 seconds. Now, let's see what happened step by step. Since we are using a preemptive priority scheduling, the student with the highest priority, which is the smallest number, gets to speak first. So here is the process execution. Number one is at times 0. Student A priority 3, starts speaking. Second, at time 2, student B arrives. Since 5 has a higher priority, A is interrupted and B starts speaking. Number 3 is at time 5, student B finishes, student A arrives. Number 4 is at time 6, student C, which is priority 2, arrives. Since C has a higher priority than A, interrupted again, and C starts speaking. At number 5, at time 10, C finishes, A finally resumes, and completes speaking at 9 seconds. Now, let's fill in the table step by step. So, this table shows important details about each process. We have process, the student speaking, which is A, B, and C. Priority, a lower number means higher priority. 1 is the highest. Arrival time, when the student arrived. Burst time, how long they needed to speak. Start time, when they actually got to speak. End time, when they finished speaking. Preemptions, how many times they were interrupted. And turnaround time, which is the total time in the system. Waiting time is the time spent waiting before speaking. So this will help us track who spoke first and when, how long they waited before speaking, and if they were interrupted. So in step 3, which is filling in start and end time, you can see here in the table the process priority arrival time burst time. The only thing that we don't have is start time and end time. So in student A, their start time is 0 and 5 because A had two start times because it was interrupted twice. Their end time is 9 seconds. So in B, we have 2 seconds because B executed first when it arrives at time 2 and finish at a time 5. In C, it started at time 6 and finish at a time 10. So this is the step 3, start and end time. Now, looking at the execution order, we fill in a start time and end times. So let's move on to step 4, which is calculating turnaround time. So turnaround times tell us how long each student stayed in the system. So their formula is wait T A T equals end time minus arrival time. So we're going to minus end time, sorry, to arrival time. So let's do this. 9 minus 0 equals 9, and 5 minus 2 equals 3. 10 minus 4 equals 6. So student A had the longest turnaround time, which is 9 seconds because of the interruptions, and student B had the shortest turnaround time since it had the highest priority. In step 5, which is calculating waiting time tell us how long a student waited before speaking. So we have the formula, which is WT equals turn around time minus burst time. So let's do the waiting time. Let me just adjust that. So 9 minus 5 equals 4, and 3 minus 3 equals 0, and 6 minus 4 equals 2. So student A waited the longest, which is 4 seconds, because it was interrupted twice. Student B didn't wait at all because it had the highest priority, and student C had to wait 2 seconds before speaking. For the final, we have step 6, which is adding preemptions and completing the table. So we're gonna complete the table. We have process A, B, C, and the priority 3, 1, and 2. Arrival time 0, 2, 4. Burst time 5, 3, and 4. Start time. A has 2, which is 0 and 5. B is, they have a 2, and C has 6. End time is 9, 5, and 10. Their preemptions is the student A preemption has 2 because A was interrupted twice at time 6 and at time 2 and time 6. B and C has 0 because they were never interrupted. So in turnaround time, we're just gonna minus 9 minus 0 equals 9. 5 minus 2 equals 3. 10 minus 4 equals 6. 9 minus 5 equals 4. 3 minus 3 equals 0. 6 minus 4 equals 2. So yeah, this is the table of the preemptive priority scheduling. So I hope you guys listen. Before we end, let's answer this reflection and discussion. So, number one, which process finished first and why? So, the student B finished first because it had the highest priority, which is one, and was allowed to execute as soon as it was arrived. Number two, how did the priorities affect the scheduling order? Um, Higher priority students spoke first, while lower priority ones had to wait or got interrupted. 3. What would happen if all the process had the same priority? I guess they would execute in order they arrive, like first come, first serve. 4. How would starvation be a problem in real systems using this algorithm? Low priority tasks may never get a chance to execute if new priority task keeps arriving. Number 5, how can aging help in such systems? So, aging increases the priority of waiting tasks over time and preventing starvation. So, in conclusion, preemptive priority scheduling ensures that higher priority tasks execute first, but lower priority tasks may be delayed. Understanding this helps in managing tasks efficiently and improving system performance. So that's all. Thank you.